Hello everyone, and welcome to the Decision Trees and Random Forest with Python lecture. In this lecture, we'll show you how to use Scikit-Learn in Python to create decision tree models and random forest models. Let's go ahead and jump to the notebook to get started. Okay, the first thing I'm going to do is import my libraries. First, I'll start off with pandas and numpy as np, and then my visualization libraries, which as always is matplotlib.pyplot as plt, and seaborn as SNS. And then since I'm using a Jupyter Notebook, I go ahead and say matplotlib inline. Now let's go ahead and grab the data. The data we're going to be working with is the kyphosis dataset. So we can go ahead and start typing in KY and click tab and it will autocomplete. And then we can check out the head of this dataset. So this dataset essentially represents a number of patients who had kyphosis, which is a spinal condition, and then they had an operation. And that operation was a corrective spinal surgery. And this data frame basically represents whether or not the kyphosis condition was absent or present after the operation. And the age is the age of the person in months. So this is data on children. The number is the number of vertebrae involved in the operation. And the start was the number of the first or topmost vertebrae that was operated on. Again, you don't need to know too much about the medical condition and what's actually going on here, since we're really just going to be dealing with all these columns as numbers and the kyphosis as essentially a target, absent or present. Let's go ahead and move on with a really simple exploratory data analysis. Since this data set is actually quite small, and we can check that by doing the info method, you'll notice there's actually just 81 entries, so quite a small data set, meaning I can just call SNS pair plot. Let me make sure it was imported as SNS up here, not SN. Pair plot, pass in my data frame df, and set hue equal to the kyphosis column. And let's go ahead and run that. And here we have our pair plot where we can see how the columns are related to each other, as well as the distribution. Let's move on by going straight to the machine learning modeling side of things by training and testing split our data. So we'll say from sklearn cross-validation import train test split. I want to set my X data to everything but the target. So that's going to be df drop, and the target is kyphosis, because basically we're trying to predict whether a patient, after a certain number of months after their surgery, are they healed or not? Is the condition still present? And I'm going to go ahead and say axis is equal to 1, and then we'll go ahead and say the target is the kyphosis column. Then we call train test split as always, and grab the boilerplate code over here that we can just copy and paste. I'm going to copy and paste that, and then I'll set my test size to 0.3, and we can just go ahead and use the default random state, or you can pass in 101, whatever you prefer. Let's go ahead and start off by just training a single decision tree. In order to do that with Scikit-Learn, you'll say from sklearn.tree import, and then you'll call decision tree classifier for classification. And then we will create a model called dtree of the decision tree classifier. Go ahead and instantiate it. And just like all our other models with Scikit-Learn, we'll go ahead and fit this model to the training data. So xtrain, ytrain. And then it will show you the various parameters. The default ones are fine for now for our decision tree classifier. We'll go ahead and evaluate how well our decision tree was able to predict, based off of these columns, age, number, and start, whether or not kyphosis is still present in this child. We'll say predictions is equal to dtree predict off the test set, x_test, and then we will say from sklearn.metrics import, and we'll go ahead and import classification report and the confusion matrix. And then we'll go ahead and just print those out. So we'll call print confusion matrix off our test data and off our predictions. And we'll do the same thing, except instead of confusion matrix, it will be the classification report. And we can actually tab autocomplete here as well. And let's go ahead and put in a new line between these two, just for readability. All right, so it actually looks like we're doing pretty good to some aspects. We are mislabeling about 6 of these from the test set, which gives us about an average total of somewhere between 70 all the way up to 87%, depending on what metric you're qualifying, either precision, recall, or your accuracy. All right, now let's see how these results compare to a random forest model. What we'll go ahead and do is say from sklearn.ensemble import random forest classifier. And the reason random forest classifier is under ensemble instead of .tree is because remember random forests from the theory lecture are a bunch of essentially decision trees, and it's an ensemble of them with certain caveats, such as the splits being chosen randomly, etc. We're going to go ahead and create a random forest classifier model. We'll state it's RFC, random forest classifier, and we'll go ahead and say the number of estimators is equal to 200. And you can go ahead and play around with this estimator number, see what works better for you or what works worse. 200 should be fine since our data set's actually quite small. That's actually probably overkill, but we'll go ahead and just leave it at that to reflect a normal situation. Then we'll say rfc.fit, and we'll pass in x_train, y_train. And then we'll go ahead and begin to fit our data. So we'll say RFC predictions, or pred, is equal to rfc.predict off of the test data. And then we can go ahead and print the confusion matrix and the classification report. I'm actually just going to grab this up here, copy that, and paste it here. And instead of saying predictions, I will replace that with our rfc_pred. And here as well, I'll replace this with rfc_pred. Let's go ahead and run this and compare the results to our decision tree. All right, just looking at the results here, we get about 88 precision, 84% recall, 86% F1 score, essentially a measure of accuracy. And here we're looking at 87, 76, and 80. So it's a little hard to tell which performed better because it really depends on what you value, whether you value precision or recall, and if you value it for being absent or present. So it's probably more important to realize that it's still present versus it's absent. But again, it really depends on the situation and the patient itself and what costs are associated with each of those decisions. What's also useful to compare is the confusion matrix here. So we can see the confusion matrix, we have 1 and 5 being mislabeled here, and we also have 1 and 3 being mislabeled here. So overall, it looks like the random forest did a little better. And you'll notice that as data sets gets larger and larger, the random forest will pretty much always do better than a single decision tree. Here, because the data set's so small, the random forest wasn't able to outshine the decision tree by as much. And the other issue with that as well is if we take a look at the kyphosis data set again, so we'll go ahead and just look at DF. If we take a look at the actual kyphosis column, and then we take a look at value counts, notice that we have a lot more cases of it being absent versus present. So already our label in our data set is unbalanced. There's a lot more instances of absent versus present, and that can also affect models as you go along. So keep that in mind as you're comparing decision tree in this case versus a random forest classifier. But overall, in pretty much most cases with larger data sets, a random forest classifier will outshine a single decision tree. Now, one thing I wanted to note is the use of, if we go back to the actual lecture notebook here, and notice here in the middle of the figure, there's actually a quick aside to visualizing your tree. Scikit-Learn has some built-in visualization capabilities for decision trees, and you actually won't use it often because you'll probably just be using random forests, which are much harder to visualize in this sort of manner because you have hundreds of trees versus just one decision tree. But you can go ahead and explore this code here in order to see the visualization of a decision tree. There's a couple things to note. One, it relies on a library called PyDot. PyDot does not come included with an Anaconda distribution or a normal Python distribution. So you'll have to go back to your command line or terminal and type in pip install PyDot. That's pip space install and then PyDot, P-Y-D-O-T. That will allow you to run this code. And the second thing to note is that this very last line, graph.createPNG, will also not run unless you have the graph.viz library. The graph.viz library is an additional library that will actually be able to take this graph object and create a picture from it. And this graph library is actually, this graph.viz library is not a Python library, it's another program essentially altogether. So you would have to download that separately, which is why we actually won't go through this since it's quite a tedious task to download it and install it and set up the paths, and you won't really be using a single decision tree throughout the rest of the course as far as visualization for it. So we'll go ahead and just show you the link on where you can install it. You can go ahead and just Google search graph.viz. That's going to be GRAPHVIZ, or just go to graphviz.org. And this is graph visualization software. So it's a completely separate software from Python that you have to download in order to see that visualization. So as an option, if you want to see those visualizations, you can come to this website, scroll down till you see download, and you'll click on the download link. It should show you the packages. They have download links for Mac and Windows. If you're on a Windows computer, keep in mind that you'll have to set up the path variable yourself. It's no longer automatic. Again, like I mentioned, it's quite tedious just for that simple visualization, which is why we're leaving this as completely optional for you to undertake if you want to. And you can go ahead and post to the Q&A forums if you have more questions about this. But we'll go ahead and end our lecture here. Again, you can check out the full notebook of decision trees and random forests if you want to reference the code for the visualization. But what I want you to more importantly get out of all this is the ability to just call decision tree from the sklearn.tree and compare it to a random forest, calling that from sklearn.ensemble. Random forest is an extremely powerful tool when it comes to machine learning algorithms, and a lot of times it's a data scientist's first quick choice for creating a very fast classification model as far as just trying to see what's kind of a baseline accuracy or precision or recall you can get from a model before you start kind of playing around with other models or tuning stuff. A lot of times you'll just quickly slap on a random forest classifier on it or random forest regressor, check it out and see how it does, just so you can get an idea of what's actually possible with the data. All right, I hope you enjoyed the lecture. Thanks everyone.